The strategy design pattern, the intent is to define a family of algorithms, but we encapsulate each one, so we don't want to disclose the details of the algorithm, but make all those algorithms in the same family interchangeable. That's the intent. So that strategy pattern lets the algorithm vary independently from clients that use it. So applicability. So many related classes differ only in their behavior, and this pattern, strategy pattern, provide a way to configure a class with one of many behaviors. So you need a different variants of an algorithm, and then the algorithm uses data that client shouldn't know about that. And then the class defines many behaviors, and these appear as multiple conditional statements in its operations. But instead of using multiple conditional statements, we use some polymorphic behavior in the strategy class. So that's applicability. So strategy pattern has three participants. So first, the strategy, that participant that defines an interface common to all supported algorithms. So all supported algorithms should implement this interface. And then context uses this interface to call the algorithm. And the concrete strategy is the actual algorithm. The context is the one to use one of many algorithms depending on which one is set. So the class UML diagram looks like this. So context owns a strategy interface variable, and then you have several implementation of the strategy. So here we have a set of algorithms that context uses. But instead of having multiple conditional statements, whichever is just set to this variable, that one is used by the context. So depending on situations, the variable may take one of those value, maybe changing, then whatever is set at the moment, then context can use that algorithm. So this is a strategy pattern. So one example, we are going to do some robot study. And the robot has several behaviors. So we wanna make a program running under the strategy design pattern. So first, design I behavior interface, which is common to all algorithms that robot uses. And then we have a set of concrete algorithms which implements the behavior of the robot. So we have aggressive behavior, defensive, and the normal behavior. And each of them defines a specific behavior. So in order to decide the action, the context needs some information like robot sensors, the position and the obstacles and so on. Depending on the situation, one of the behavior algorithm will be used. And then context robot uses the strategy. Here is a UML diagram for that. So robot is a context which owns a strategy variable, and then one of the behavior is set to the variable, and the robot simply calls the behavior, then the whatever is set will be run for the robot. So here is example. So first, a robot is a context to use the strategy. Let me go back to UML diagram. Then robot owns a behavior, and then in terms of a participant, the context is configured with a strategy and has a reference to the strategy object. So that's the context participant. So the context participant robot has a reference to the strategy behavior, and then the concrete one is a set. Concrete one is a set to this variable. So whenever the robot needs algorithm for move, that is simply call algorithm, define a set in this variable. So behavior called move command. So move command is the algorithm. Whatever behavior concrete strategy defined, that simply uses a move command to call the algorithm. And then strategy is I behavior. So strategy simply defines common interface to all algorithms to use. So in terms of participant, the strategy simply declares a common interface to all supported algorithm. Now we have a concrete strategy. Here is aggressive behavior, implement a strategy, and then move command. This is detailed algorithm for aggressive behavior. Similarly, defensive behavior, and then normal behavior. So the entire program, as you create robots, and then for each robot we give appropriate behavior for the situation. So we assume that R1 sensed some obstacles or enemies and so on, so the R1 is now ready to do some aggressive behavior, and then R2 senses that enemies are too strong, so defensive behavior. So R3, no enemies around, so it's something normal, so normal behaviors then. And then simply call move, then whatever behavior is set, then that one will be used. So later on something happens, then R1 can change the behavior, R2 can change its behavior, and then 3 robots continues to move. So this is a demonstration of a strategy design pattern. So another example is a vehicle example. So we have a vehicle, and then several kinds of vehicles. We have a Formula 1 race car, and helicopter, street racer, and the jet. And then all the vehicles uses a set of algorithms to drive. Go by driving, or go by flying, or go by flying fast. And then those are a set of driving algorithms, and then interface Go algorithm provides a common interface for all the algorithm. So in this example, the vehicle is a context of the strategy pattern. Go algorithm is a strategy, and then those 3 driving algorithm or flying algorithm is a concrete strategy. So example program looks like this. So we have another set of classes for another example. So first of all, vehicle is a superclass of all vehicles defined in this example. Formula 1, helicopter, jet, and street racer, car, those are subclass of a vehicle. And this is a context of the strategy pattern. So you have a reference to the strategy. So Go algorithm interface, so that's a reference to the strategy. So whatever real strategy, driving or Go algorithms set, and then simply say Go to move the vehicle. So subclass of a vehicle, let's take a look at one by one. And then street car, simply child of a vehicle. And for street car, the best algorithm is Go by driving, and the jet is Go by flying faster, and the helicopter is Go by flying, and the Formula 1 is Go by driving. So depending on the type of the vehicle, the driving algorithm is set. Then we have a strategy. So strategy is a Go algorithm. So strategy is common interface to all supported algorithms. Simply Go method is defined, and then Go by driving. The Go method is how to drive, by flying or by flying fast, and those a set of going algorithms for the vehicle is defined. So the main application looks like this. So you have a street race car, Formula One, and helicopter and the jet. So for each subtype of a vehicle, the algorithm is set. So if we simply say go, those vehicles move. Also, using the strategy pattern, we can implement some complex type of a vehicle which is not clearly precisely defined in one of the subclasses. So suppose we need a real jet, then first the moving algorithm for this vehicle is go by driving, which is drive on the runway to take off. So it was driving on the runway ready to take off, and then set the algorithm for flying faster. So it's flying now, and then when it land on, we go by driving again. So using this, by changing those algorithms depending on the situation, we can precisely emulate the real jet. So this is a demonstration of a strategy design pattern.